Alright, so I'm going to use this video to refresh you guys on Punnett squares a little bit. So Punnett squares are these boxes with a cross in the middle. Gives us 4 possible small boxes. We use Punnett squares to help us try to determine the probability of getting different genes. Now we know that genes are what causes our traits. So our traits are like our hair color, our eye color, how tall we are, things like that. Those are all controlled by genes that are kind of like information for our body to read. But we all have different traits, right? Some of us have different colored eyes or hair. And so there's different forms of genes. So there are different forms of the eye color gene because one is the information for blue eyes and one's for brown eyes. And we call those alleles. And so an allele is a different form of a gene. So it's the same, it's a hair color gene, it's an eye color gene, but one might be a different color, right? One might be a set of instructions for brown eyes or blue eyes. So in this video I'm going to use the example of dogs. This is a short-haired dog, this is a long-haired dog. So they both have a gene for what kind of coat or what kind of hair they have or what length, but they both have different genes. So the gene we're going to look at is coat type. Okay, but both of these dogs have a different form of that gene. One has a short hair, one has a long hair allele. Those alleles are different types of the gene. So different types of the coat hair or coat type gene. There's both coat type genes, but they're different lengths of coat. So we would call them different alleles of that gene. Okay, so with Punnett squares, we usually have one gene that is dominant and one that's recessive. So we're going to say that for this example, the short hair gene is dominant and the wiry hair gene is recessive. Now, what that means, a dominant gene or a dominant allele means that any time you have that allele, or your body has that allele in its instructions, it's going to listen to that. And a recessive allele kind of gets bullied a little bit, doesn't always show up. So the dominant gene always presents itself. If you have a dominant allele, you will have a dominant trait, whereas recessive has to have a buddy, kind of gets pushed around a little bit. So if you have a recessive gene, you might have that allele, but your body probably does not listen to it unless you have 2 of them. So let's look at how to fill out this Punnett square. So with the Punnett square, we put dad's genes, his 2 alleles, on one side, and we put mom's alleles on one side. So I'm going to pick the top for dad and the side for mom. The boxes show us what are all the possible combinations of alleles the baby could get, because we know that dad is going to give 1/2 of his genes, mom's going to give 1/2 of her genes. So these are both like the dog parents in this example. And we're going to put their alleles on the top and on the side, and then we're going to fill this out to see what are all the different possibilities of genes these dogs could get to determine whether they have a long coat or if they have a short coat. So we're going to say mom's genotype was dominant recessive, so mom would have a short coat. We're going to say dad's genotype was also dominant recessive, so dad will also have a short coat. So you would think that all the babies would have short coats, but that's not necessarily the case, and we'll see why. So I'm going to take mom and dad's genotypes and I'm going to put them on my Punnett square on the top and on the side. Then I'm going to distribute down from the top. From the other top letter, I'm going to go down, down. Okay, and then from the sides, I'm going to distribute to the right. So I'm going to distribute to the right. And I'm going to distribute to the right, to the right. Now it doesn't matter what order they're in there, and I'm going to distribute to the right. So these boxes show all the possible combinations of genes, of alleles that these puppies could get. Because mom is only going to send one of her alleles, and dad's only going to send one of his alleles. So if we look at this, this is all the different combinations that the puppy could have. And you'll notice that here I have 2 recessive alleles. So that means that the puppy, if you got 2 recessive alleles, even though both parents had the short coat, those recessive alleles would make the puppy have the wiry coat. So we can see that I have a 75% chance of having the dominant trait, which is for short coat, but there's a 25% chance of having a recessive trait, which is the wiry coat, even though both parents had that short coat. So hopefully this helped out a little bit. Please let me know if you have any more questions.